Hello. In this segment, we're going to be talking about some data communication concepts. In a network, we find four major components or elements: protocols, messages, media, and devices. Protocols are the rules about how messages are sent and received, directed, and interpreted. And so these are like grammar in a human language. The messages, then, are the data that are sent and received as part of a communication. There are two parts to the message. There's the protocol header and then the data payload. The protocol header is the envelope in which the data is actually carried. The media is the material through which the messages move. It could be wired, such as copper, or it could be fiber for conducting optical, or wireless using radio waves. The devices, then, are the equipment that send, receive, or direct messages through the media. These could be endpoints or intermediate devices such as switches and routers. There are two major models that we examine when it comes to data communication: the OSI model and the TCP/IP model. The OSI model does not specify concrete protocols, but rather is very abstract and instead specifies the functions that the concrete protocols will need to implement at each layer. These layers, the 7 of them in the OSI model, are the application, presentation, session, transport, network, data link, and physical layers. The physical layer transmits raw bits in either code words or symbols. At this layer, there's no knowledge of the data that's being transmitted. So for example, high and low voltages over copper or twisted pair wire or colors of light and fiber is what we would see at this layer. At the data link layer, we group bits together into units that are called frames. Frames are sent and received on a single network only. These handle synchronization and collision detection or avoidance, and the examples here are token ring, Ethernet, fiber optic, and wireless. At the network layer, it's possible to send units of information, that is packets, across different networks. And so now we're talking about internetworking using routing. At this layer, we have to have uniform addressing across the globe, network congestion control. Protocol examples include things like the Internet Protocol, IPX from the Novell era, and ICMP, the Internet Control Message Protocol. The transport layer ensures the reliable delivery of packets through error recovery, flow control, congestion control, and multiplexing of the network by several applications at once. The examples here include TCP, the Transmission Control Protocol, and UDP, the User Datagram Protocol. The session layer is going to provide enhanced end-to-end session services such as authentication and authorization for security. Example protocols here are things like the Password Authentication Protocol, NetBIOS, and the Point-to-Point Tunneling Protocol. At the presentation layer, we manage the way data is represented and formatted through encryption, compression, serialization, and encodings. We've talked about encodings before. These include ASCII and Unicode, as well as a higher level example such as XML. At the application layer, we're going to see individual protocols for each program that we're running. So, File Transfer Protocol, SMTP for Simple Mail Transfer Protocol, SNMP, the Simple Network Management Protocol, the Lightweight Directory Access Protocol, and the Hypertext Transfer Protocol spoken by web browsers. Most of these are going to be defined in Internet RFCs, requests for comment. The TCP/IP model, in contrast to OSI, is a real-world protocol stack that's used for most communication over networks today. Contrasting these two, we see that the TCP/IP model on the right combines the top 3 layers of the OSI model into one massive layer called the application layer. We still refer to this as layer 7, just as we refer to the transport protocol as layer 4, the network as 3, the data link as 2, and the physical as 1. In the OSI and TCP/IP models, we see that the layers separate the concerns and allow us to build interoperability between different manufacturers. This is nice because we can take out one particular protocol at a layer and plug in another, and we don't have to modify the surrounding layers. Each layer that we move through adds a layer of encapsulation as we send the packet and decapsulation as we receive the packet. So for example, the application layer data is the message. This gets encapsulated using a header at the transport layer. The transport layer and the message get encapsulated into a layer 3 IP header, and so on all the way down the stack. When things get transmitted across the wire, on the other end, as the message moves up the stack, we take off those surrounding envelopes until we deliver the unaltered message to the application on the other side. Intermediate devices can examine headers and reformat the protocol data units for the next hop. This is especially true if we're moving from one media type to another, for example, from wireless to wired networks. As we move down the protocol stack on the left and across the physical layer to the intermediary node, it moves up, but not all the way up to the application layer. It might only move up to the IP layer for routers. For switches, we might only move all the way up to the data link layer. And it examines the protocol headers, figures out what to do with the packet, forwarding it out a particular port or a particular switch, and then sending it on its way. On the far side, we receive those and decapsulate on the way up. We find several different kinds of topologies in networks: buses, which require arbitration of the bus, as we've discussed before; rings, in which a token is passed along among all the different elements. You can send or receive whenever you have the token; a star network, which is common for switched networks today; mesh networks, which are fairly common in wireless; and even hybrids of those in the extended stars and the hierarchical. In summary, networks consist of 4 elements: protocols, messages, media, and devices. The OSI model provides 7 layers of abstraction that are concretely provided in the 5 layers of the TCP/IP model. As data moves down layers, it gets encapsulated in the lower protocol data unit formats, and as it transmits across and then moves up the other layer, it's decapsulated. Networks can be arranged logically and physically as buses, stars, rings, meshes, or hybrids.